Hello, in this video, we'll be going over plotting your data. So we'll be continuing from the last tutorial, which was the mapping. So we have the New Hampshire data, some polygons selected, and I will go ahead and we'll plot the data using ForMaple's plotting functionality. Alrighty, so let me go ahead and open up my ForMaple here. Here we have our polygons, our north, our third polygon, our New Hampshire data. We can go ahead and go to the plot tab. And so the plot tab is really cool. This is where the meat of ForMaple is. I'm really proud of what we were able to do here with this kind of on-the-fly aggregation and all the cool options we have with our plot. Okay, so the first thing you'll see is this plot controls on the left. So what you can do is you can select by either your plot keys or your polygons. So what this will do, let's say plot key, for example. You take a look and see what this says. If multiple plots are selected, the data is aggregated and summarized in a per unit area. Let's go ahead and click Select All. So this is going to do, so this will take all of our New Hampshire plots, and it's going to aggregate them on a per acre basis. So here we can see the first type of plot we have is the diameter distribution plot. By default, it's going to put it in 4-inch bins using the range of your data. And because the data is in inches and acres, or in imperial units, it'll use that. If your data is in metric, so centimeters and hectares, it'll use that. So since this is FIA, it's an imperial, so we get a diameter class in trees per acre. So by default, plot key is going to take all of the plots in your data. And an important caveat is, the plot only has access to whatever survives in your filtering. So if you filter plots for a certain criteria, and you come here to plot key and select all, it will only pull out those plots that meet that criteria. So in this example, I'm going to use all the plots, but if you want to filter your plots beforehand, you do so in the Filter tab, you build your statements, come back to the plot, select them all, and it will pull only those plot keys out to get your per unit area values. I'll come back to the sampled plot in the latest year here in a little bit. So what can we do in the plot tab? First thing is we have this little accordion panel where we can first start with our data. So by default, you're going to see group variables are blank, legend variables are none. What does legend variable do? So if we come here, we can see it says choose for colors, data summary. So if I come here, let's do a legend. So let's say we want to look at our diameter class by, I don't know, the typical one is species. Let's just do species. We'll do scientific name. This will then take our data and it will bin it up by the different species in those diameter classes. And what's really cool about ForMaple is that if you have too many species that are going to overflow this legend, you can basically tell it to take your species in terms of their abundance. So you can only see the dominant species on your plot, for example. So by default, it's going to show you the top 10 species by basal area on the plot, sorted by ascending abundance, or descending abundance, excuse me. So the most abundant plots are going to be here at the bottom, and the least abundant are going to be at the top. And if you want to show certain plots or certain legend items, you can come here and filter. Let's say I only want to see yellow birch, hemlock, Acer rubrum, sugar maple, and let's just do basswood. We can do this. So what's really cool about this is that on the fly, it's going to show you your category. So you can see Acer rubrum, eastern hemlock, yellow birch, sugar maple, and American basswood, and other. So everything that isn't selected here is going to fall into what we call the other category. So the other category is just everything else in that legend. So all the other species, they're not going to disappear from the plot, but you can still see them, which is really cool. So if I want to, let's say, have these appear on the top of the bars, I can do on the top. Then it's going to put these other variables on the top, and it's going to adjust the palette on the fly. If I want to have this be in line with the data, so it follows the abundance order, it can do that. Or if I want it to be hidden, I can hide that, and it will just show the species I'm interested in, which is pretty cool. And so we can do this not for just scientific name, we can do this for things like, let's do county code, for example. We can do county code. Any variable here you can plot by. So county code, we can now see the different counties. And if you want to change how this is ordered, we can do arrange it alphabetically. So it'll do, that's funny. I guess in this case, it treats us as a character. So technically 11 comes after 1. Sorry, there's not much I can do there to fix that. We can't have numeric values without it getting converted to a character, unfortunately. But you can see we can split this up by county code, which is really cool. We can sort again by TPA if we want to change the order. And we can do abundance descending, and all this good, cool stuff. So that's really cool. You can basically change how your data is ranked and whatnot. So let's go back and make this, species again. Let's do common name just so we can all see this here. Interesting. That's quite interesting. Let's do abundance descending. There we go. That's why it was all weird. So now these are the top 10 most abundant species. I guess, yeah, if you wanted to, you could do abundance ascending. This is going to pull up the top 10 least common species, which would be kind of weird. Like this. This will pull out the top species. So, however this is arranged, this will also change your legend filter. So we can see that things like eastern red cedar, Callery pear, hawthorn, sassafras are the most uncommon top 6 species in New Hampshire, which makes sense. If I go ahead and make this abundance descending by BPA, now we can see these guys are the dominant ones which are selected. Okay, now we have that. Now we have this grouping variable. So by default, it's just going to color it by your per acre or per unit area values with your legend. That's cool. You want to split this up into different subgroups. Let's say ownership, or whatever variable you want, you can do this. So let's say we want to group our data by owner group code. So what this will do is we'll take the data, and for every group that data falls into, it's going to split it up and aggregate it on its per unit area basis. And so this is dynamic and on the fly. So each group will always contain a total number of plots that it can aggregate by. And so we never double count plots, make sure that all of the math is correct and nice and neat on the fly. So we can see now we can look at our data by different ownerships. And if you want to pull out a specific group variable, we can come out here and pull out just a single one. Let's say private land, for example, we can pull that out and compare it to, I believe this is federal, I think so. And you can just easily mix and match your selections here. And you don't have to just use one group variable. If you want to select all of these and group this by year, you can see how the different ownership codes change by year. So let's say we want to look at just the year 2019 versus 2025 in this inventory cycle. We want to look at federal versus private. You can do this as well. So you can mix and match however you want your data to be grouped, and you can see it just like this. I'm going to go ahead and clear this so we have one nice little plot here. Okay, so that is how this works. That's your data tab. You can do all this cool filtering, grouping, however you want. It's really nice. And we have binning. So let's say you want to bin your data into different classes. By default, we can plot our trees by trees per acre. We can also do basal area per acre. So if you want to see a diameter, basal area per diameter class, this will use whatever units you have, which in our case is feet squared per acre. You can quickly and easily mix and match this on the fly. We also have size classes. So let's say in diameter class, if you want to have bigger bins, we can make this like 10, for example. Now we have 10-inch bins. We want to change the upper or lower ends of our data. Visually, we can say we only want to look up to 24 inches. We can do that, and it's going to pull out just that data. And so we also have diameter class method. So by default, it's going to use the typical forestry breaks. So the 1-inch class is 0.5 to 1.5. So basically, you take the range and you get the midpoint, and that's your break. If you want to have linear methods, so like 0 to 1, 1 to 2, you can disable this, and it's going to restructure your data, it should. Maybe I just discovered a bug. Not going to worry about that now. But pretty much you just want to have this enabled at all times. Just keeps it traditional with what you would expect from typical forestry size classes. Or diameter classes, excuse me. We also have size classes. So if you want to break your trees up into things like sapling, pole, and saw, by default it's going to use sapling, pole, saw. And you can set the boundaries. So 0 to 5 inches is sapling, 5 to 11 is pole, and 11 to whatever your max data is saw. You can go out and pull these out. Just look at the ones you want in the filter. You can change the number of classes. So if you want 4 classes, for example, and you want this class to be, let's say, 11 to 20, then 20 plus, you could call this big saw. So you can set up your classes and change the labels, and it's going to bin your data on the fly with whatever you set your class to, its range. And again, this works with both TPA and BPA, so that's pretty cool. I'm going to leave this here. It's kind of cool. I like this big saw. Sounds nice. That's the binning. So you can set up your how you want your plot to be, TPA, BPA, diameter class, size class, number of bins. We'll come into references later, but next we have appearance. So we have all this cool stuff. We can unstack the bars. So if you want to have your species shown stacked or unstacked, you can just click this and it'll unstack the plot. You can change your theme. So if you want a different theme, you can just cycle through these. And these are just the ggplot default themes. Void is cool if you want to have your own custom axis and whatever. You can just get the colors and stuff. You can do that with whatever you want. Let's use gray. It's the nice default. Change your palette. Again, a bunch of predefined palettes. One thing similar here to the map tab is the fixed palette. So if you don't want this to change for your legend variables, let's say you have all your species and you want it to be fixed and never change depending on whatever data you're showing, you can fix palette. What this will do, it's going to rescale your data according to every tree in your data set. The reason this looks so dark now is because we have data ranging from A to Z by common name, and it's making the palette based upon that. If you unfix the palette, it's only going to base the palette based upon the selection that you have shown, which, depending on what you want, you can pick and choose what you want there. You can set the legend position, left, top, right, bottom. You can hide it if you want. You can choose the number of columns in your legend. Let's say you want your legend on the bottom, but you want this to be you want there to be fewer columns. You can say I want 2 legend columns, and it'll split your legend into these number of columns here. Go ahead and make this right again. Make this 1 column. You can change the transformation. So if you don't like linear, you can make the square root. And I only recommend this if your data is unstacked, just so that the scale is consistent. Now we can see the big saw. We can flip our plots. We can go ahead, change how that looks. We can add titles. My awesome plot. There we go. You change the axes. Shows up there. Change the y-axis. By default, it's going to use the correct units for your data. Change the legend title. So if I want this to be species instead of common name, you can do that. Most of this ggplot stuff, it's pretty self-explanatory. You can do all this cool stuff that you want. Change angles, change font sizes, all this good stuff. That's really cool. Okay, so the next thing we have in our diameter distribution is what we call our references. So for right now, since we're working with primarily the Northern Hardwoods data, we've implemented what we call the Arbogast reference. So within your plot data, if you go ahead and select a reference curve, what it's going to do is that it's going to rescale your data according to a standardized reference. So we go ahead here and, let's go ahead and make this a little bit easier to see. Go back to TPA. We're going to show this on the bottom, and we're going to unstack this. My stack appearance. There we go. Okay, so cool. So now we can see that in New Hampshire, interesting, it appears, I haven't actually looked at New Hampshire compared to the rest of the states, but in the lake states, it's different. But we have our reference line, so we can see what the TPA should be per each class. If we go ahead here and change this back to diameter class, you can see here, interestingly, we're quite overstocked in all of our diameter classes according to the Arbogast reference. All this is just a reference curve for TPA and BPA. It shows you where you should be stocked relative to something else. Let me make sure this isn't bugged here. No, it's not. We're just way overstocked. That's crazy. For New Hampshire. That kind of gives you an idea of how these reference curves work. Again, for Arbogast, we'd only use this in the lake states, but it's just an example of it's here. So if you work in the lake states, you have that reference line. You can show and hide the reference line and see the difference by size classes, which is cool, or whatever you have selected. You can do all that cool stuff. And go ahead and make this back to size class by BPA, and you continue here. Okay, so now we have the plot talked about, different stuff you can do in your plot. The next step is actually the data. So what can you do with your data? So if you're happy with the plot, you can click Download Plot, and it will save an SVG graphic to, let me make this out of full screen here. Go ahead and click on it. You can see it saves a really high quality, high resolution, lossless plot that you can go use for publications. You can choose the format. SVG, I'd recommend PDF, PNG. You can change the DPI. The next thing is your data. So all the data underlying your plot you can access here in this data tab. So what this will show is it will show your legend variables, whatever you have for your size classes, your diameter classes, the TPA, BPA, and this is really important. Here we have the number of plots, the number of sampled plots, the plots that are being used to aggregate your data to a per acre basis. So what this is saying is within New Hampshire, we have a total of 1,153 plots. This is the N plots. However, the S plots is the number of plots that actually contain forested data. In this case, it's 1,038 plots. And so this is important depending on how you aggregate your data. If you're only interested in forested data, you want to use your S plots. If you're interested in how this compares across the entire region, you want to use N plots. So by default, to not inflate the data, we have this option called sampled plots only checked. So you can go ahead and read this here. But basically what it's saying is, if you leave this unchecked, by default it's going to use the total number of plots in your aggregations per unit area. If you check this, for example, you'll see this changed, the use plots changed to the number of sampled plots. So this is only going to use the forested plots to aggregate your data. Depending on what you want to do, you can choose whatever you want here. You can see that depending on what we have checked or unchecked, the basal area does change based on how that is being divided. Not by much here in this case, because we're only talking about around 120 plot difference, but that does change the value. And if you're looking at just forested values, that will increase your TPA or decrease it depending on how you want to aggregate your data. And so again, we can take this data, you can download this. It's a download, and we go ahead and download it here. And you can go ahead and open it up as a CSV, and you can see you have all the data underlying the plot, so your common name, your species and size classes, etc. So that is the diameter distribution plot. So all that same stuff applies to what we call plot summary. So here you can make a diameter distribution plot. If you want to look at per acre or per unit area values, we have this plot summary tab. If we go over to the plot summary tab, it's going to be really similar. You have your data, you have your appearance, and you have your export data. So it's going to work the same way. You have your data, you have the variables that are being summarized, the number of plots, number of samples, etc. Okay. So, in your data, by default, let's go ahead and uncheck this here. It's going to show you plot metrics, and it'll show you, for example, basal area. You can select different summary metrics. So across all your plots, what's your average basal area? Your plot is a box plot. You look at TPA, quadratic mean diameter, species count, etc. So let's go back to quadratic mean diameter. That's a cool one. And so you can look at this as a box plot. You can do a histogram. So this will show you all of your plot counts per different classes. You can do a density diagram, a bar chart, which just shows the total value, and a scatter plot. So some of these plots don't make sense until you do grouping. So if I come to our group variables, we can look at this. How does quadratic mean diameter change by, let's say, ownership? So if I look at this, then we can see, okay, and we can kind of compare this by ownership. And if we want to make this all in one plot, we can set our x variable here to be this. And now we can see we have our different ownership categories grouped by quadratic mean, or our quadratic mean diameter grouped by ownership categories. We have the same sort of thing. We can do this by abundance. It'll sort those. We can filter. If we want to do alphabetical ascending, we can do that. 20, 30, I guess 10 comes after 40. I don't know why. You can deselect stuff depending on what you want. And similar, it'll put it in the other category. So again, you're comparing apples to apples. So you can see 40 to other. Select all. You can make those appear in line, filtered values. So all the same stuff you can do in the diameter plot you can do here. Again, appearance, you can edit all this stuff, make it be how you want it to be. And you can mix and match some crazy things. So let's say we want to look at, well, let's do multiple. Let's say we want to look at forest type code, and we want to change this to be histogram. Do this as well. We have this one's cool, the density plot. I like this one a lot. So it can show you within your owner group codes where those different plots fall in terms of quadratic mean diameter compared to each other. That's a cool plot. I don't know how useful it is for some people, but you can again mix and match all this stuff, do whatever you want. If you don't want to have this, you can just split it back up again. So that's the plot metrics. We have these 4 metrics here. We also have plot composition. So let's say you want to look at how your plot is composed as a whole. Click on the plot composition tab. The first thing you're going to see is it's going to prompt you to choose a legend variable. Let's go ahead and clear this group variable. So we want to look at plot composition by species. So what this will do is within all of our plots, it's going to show us the dominant species, again, sorted by basal area, with other being everything else that's not selected. And so we can see this here. We can see our dominant species by basal area in New Hampshire is actually Acer rubrum, which is pretty cool. We can sort it by abundance, again, alphabetical, abundance descending, however you want to do this, you can do. Sort by TPA, sort by BPA. You have a bunch of different plot charts here. So we can do, if we want a bar chart, you can do that, or you can make it a pie chart, which is cool. Show you the relative percent of each of those by scientific name. Let's see what else we can do. This, we can mix and match this however we want. So I like this one. Let's do, we want to group by, let's want to look at owner group code. So the different ownership classes, and we want to say within different forest types. This is really cool. So we can see like within all the forest types in New Hampshire, from pines to maple, we can see what percentage of ownership is within each of those types. So within type 125, which I believe is red pine, 10 I believe is all federal, which is pretty cool. We can see that type 709, all of it is actually private, which is pretty cool. So you can mix and match this. You can do things like pull out the ones you want. So let's say we want to do forest type, Maple Beach birch types, which is 800s. We can see that. It's really cool. If we don't want to do a pie chart, we can go ahead and make this back to a bar chart, and you can see all this cool stuff as well. And so this is the plot summary. If you want to look at your data, you can do this as well. It tells you the share and percentages. You can download your data and export it. And again, you can also choose to do this by the sampled plots, so just the forested plots, or the plots that the total number of plots within that group, which is pretty cool. Okay, so that is all we have for the plot summary. One thing I didn't mention is, okay, so this is actually quite important. So by default, it's selected by plot key. So if you have a polygon selection, such as the map here, like north or P3, you can also access that attribute data as well. So if I change my select type to polygon, what we can do is we can pick our polygons from our map as our plots we're selecting by. So we can come here to just these polygons. You can see our total number of plots has decreased. And so what we can do here, there's only 381 plots we've selected from this. If we want, we can also use this variable to group by. So if we want to look at, it's called polykey. And so we can see from our selections how our data differs. So within our polygons north and P3, it'll pull out just those plots we're interested in. We can see how those differ. As you can see here, we have north and P3. So you can also use your polygons like that to create regions of interest and group by those regions to see if there's a difference within your data. Alrighty. I believe that is all we have. TPA, and that's some crazy high TPA. So interesting. Okay, I will leave this as we are right now. And in the next video, we will take off looking at the area summaries. So I'll see you in that tutorial.